Hello everyone, we are live now. Today we are doing one more interesting chapter from standard 10. Name is Matrices. Matrices is not the movie from Keanu Reeves. Matrices is a chapter in mathematics. So let's see what it is. So matrix is a set of elements organized into rows and columns. So remember this, rows and columns. I'll be saying this multiple times, what are rows, what are columns, but pay attention. So there are m rows. So what you see here, the horizontal ones are the rows and there are n columns, and vertical ones are the columns. There are m rows and n columns. So m is number like 2, 3, 4, 5, 2 columns, 3 columns, 5 columns. Like this, it can be columns. So as per their order and how many numbers are there are these types. So number one is row matrix. As you can see, there is only one row. So this is row matrix. Then column matrix, where they have only one column. Remember what I said, horizontal are the rows, vertical are the columns. Then we have this rectangular matrix. Now here there are 2 rows and 3 columns. So 2 rows and 3 columns. Now this thing which we call this order of matrix. Now if you notice the fourth one, we have here square matrix. So it looks like a square. Rectangular matrix looks like a rectangle. So can you guess what is the order here? There are 1, 2, 3 rows and 3 columns. If you see previous ones, here we have 1 row. So 1 into 3. And for column matrix it was 3 into 1 because there are 3 rows and 1 column. Zero matrix again 3 by 3 matrix, but if you notice all the numbers are here as 0. And what's changed in diagonal matrix? Numbers are as per the diagonal. Let's go ahead. So till now we have seen the types of matrices. There is a row matrix, column matrix, square matrix. A matrix in which the number of rows equal to the number of columns is called square matrix. Then zero or null matrix. Matrix whose each element is 0 is called null matrix or zero matrix. And there is one thing called identity matrix. In identity matrix is a square matrix which each diagonal element is 1. Just like we have this diagonal matrix. Alright. So if I am making one more diagonal matrix here. So 1, 1, 1, 0, 0, 0, 0, 0, 0. So you can see here, it is 3 by 3 matrix and diagonally the numbers are 1. It can be 2 by 2 also. We can make it like this, 1, 0, 0, 1. So this is a diagonally there are 1. So this is called as unit matrix or identity matrix. You have to need to learn all this term and remember it. Alright, let's go ahead. Let's see few questions from exercise 8.1. Alright, if you have any doubts, you can put comments down there so I can see and I will reply to them. Alright, so I am taking blacking. Okay, this is blacking. So classify the following matrices. So we have seen here. First one, what's the order? There are 2 rows and 2 columns. So let's write 2 into 2. So what do we call this? 2 by 2. Same number of rows, same number of columns. So we call it as square matrix. Correct. Square matrix. Then here what's the order? 1 row and 3 columns. So only one row. Only one row is a row matrix. Yes. You guessed correct. Then this is 3 rows and 1 column. When there is 1 column, we call it as column matrix. Then we have it here. This is 3 rows and 2 columns. So this is rectangular matrix. Again we have one more rectangular matrix, but here the order is 2 by 3. Now here this is again 2 by 3 type of matrix. All members are 0, so we can call it a 0 or null matrix. Alright, I hope you understood the types. Now here's one interesting question. What they're saying, a matrix has 4 elements. What are the possible orders it can have? So there are 4 elements, so it can have order 4 into 1, like we earlier had a column matrix. It can be 1 into 4, it will be a row matrix, or we can have elements arranged in 2 by 2 matrix. It can be a square matrix. So let's see. So in the next question they have said 8 elements. So 8 elements will be arranged as 8 into 1, so this will be column matrix. 1 into 8, this will be a row matrix. We will have rectangular matrix like 2 into 4, or we can have 4 into 2. Can we have any other arrangement also? Any guess? Which other possible arrangement can we have? One into 8, 8 into 1, 2 into 4, 4 into 2. Can we have 3 by 2? No. These are the only numbers which gave us like product as 8, right? The product as 8. So now if you know, M is number of rows, N is number of columns. When we multiply them, what do we get is, we get number of elements. So understood why it is important? M and N, these are giving us elements. Alright, so these are the possible orders. Let's do this one. This is further more interesting. Let's go deep into this matrices. Alright, now earlier we had this M and N letters. Now we have this I and J letters. Now what are these I and J? Alright, remember when we do graph, we give each number some coordinates, right? Point A, for example, point A having coordinates 1 and 1. So this 1 1 shows its position with respect to the axis, correct? So similar way, here we have in matrices this letters I and J, its value will give us position of that element in that particular matrix. Let's see how it is. Let's take one matrix of order 2 by 2. So it will have 2 into 2, 4 elements, right? So let's say these elements are X, Y, Z and W. Alright, so it will have I and J. I is for rows, so we'll have I here, and this is J here, J here. So this is first I, this is second I, this is first J, second J. Now consider these are like axis and we're trying to find out position of X. So see, first X is 1 and 1, so we'll write like same way 1 1. Y is 1 and 2, 1 2. Z is 2 1 and W is 2 2. So these are their position with respect to that particular matrix. So that is only what we have here. A I J is these numbers, right? Now here they have given this kind of formula. A I J is equal to 2 times I minus J, right? So in place of I and J, we just have to substitute these numbers. So let's see, what is the first position we have? X 1 1. So how do we get X? We substitute these values of I and J. I and J is 1 1, right? So here I is equal to 1, J is equal to 1. So if you substitute in this one, so we'll get 2 into 1 minus 1. So 2 minus 1 is 1. So this is the first element. Alright, then if you take Y 1 2, you will take I is equal to 1, J is equal to 2. So same again, put it in the formula 2 into 1 minus 2. So what are we getting? 2 minus 2 is 0. Then z 2 and 1. So I is equal to 2, j is equal to 1. So 2 multiplied by 2 minus 1. So 2 to the 4 minus 1 is 3. Alright. And last w is 2 2. I is equal to 2. J is equal to 2. So 2 multiplied by 2 minus 2. 2 to the 4 minus 2, how much? 4 minus 2 is 2. Alright, so these are the 4 elements. So we are getting a 2 by 2, 4 elements. We got value of x is 1, 0, 3 and 2. This is our answer. Alright. Now let's do the second question here. Question number 1, question number 2. Let's see what they are given. A is equal to ij is equal to I into j. Right. So what do you have? 1 into 1, 1 into 2, 2 into 1 and finally 2 into 2. Right. So 1 into 1 is 1, 2 into 2 is 2, again 2, 2 to the 4. So these are the 4 elements. How are they arranged? 1, 2, 2, 4. So this is the answer. Alright? Isn't it easy? So R is for rows and J is for columns. Alright, let's go ahead. Next concept we have is equal matrix. Two matrices are called equal when they are written as A is equal to B. Remember, capital A is one. We give this like letter. Like in sets we have sets. We denote sets by capital letters. Capital A is equal to in curly bracket x belongs to such or like that. So same way here also we denote matrices using capital letters. So here we write as A equals B. What does that mean? A and B are in the same order, number of rows and number of rows in B, and same number of columns and same number of columns. So they have same number of rows, same number of columns. Also the elements has to be in same order, right? Their corresponding elements are equal. That entries of A and B are in same position, are equal. Alright. Otherwise these are called unequal and we write as A is not equal to B. So if we let's see in this example, you will understand this better. See first one, 4, 4, 4. They all have 4. Let's see A, B and C. These are the three matrices. Then we have 13, 13, 13. So we have completed the first row is equal. Let's say second row, minus 2, minus 2. Over here it is 19. And again 19, 19. Over is minus 2. So see, elements are same, but they are not arranged in the sequence. So see, A is equivalent to B, these are equal, but A is not equal to C. Also if we have other matrix M, this also have 4, 13, minus 2, 19, but it has this one extra row. So what we said earlier? Earlier we said number of rows is equal to number of rows. So number of rows has to be same. So as it have different number of rows, this is not equal matrix. Alright, this was easy again. So let's see a question based on this. Let's see question number 4. And what they are saying: find values of x and y if 2x plus y and 3x minus 2y is equal to matrix 5, 4. So these are equal matrix. Equal matrices, therefore their corresponding elements equal. So we get 2x plus y equal to 5 and 3x minus 2y equals to 4. So here we got two equations. These are simultaneous linear equations and we definitely know how to solve simultaneous equations. So let's solve these. So let's multiply this equation by 2. So we are getting 4x plus 2y is equal to 10. This is the equation number 1. This is the equation number 2. And if we add equation 1 and 2, we will get the answer. 3x minus 2y is equal to 4. So what are we doing? Equation 1 plus equation 2. So 2y minus 2y gone, 4 plus 3 is 7x, 10 plus 14. So here we get value of x is 2. So value of y, how are we getting? By substitution. Substitute in any of the equations. So let's say 2 into 2 plus y equals 5. So 4. So y becomes 5 minus 4. Y is equal to 1. So these sums are like so easy. Easiest sums in this whole exercise. Whole chapter actually. So we just have to find out equal elements and find out values of x and y. So let's see which other sum we can do. Let's do this one, question number 7. Alright, because it has x, y and z also. Let's find out that. So what we said earlier, x plus 2 is equal to minus 5. Then we have 6 is equal to y square plus y. Then 3 is equal to 3 plus equals. Then lastly 5z is equal to minus 20. Okay, so we got our 4 equations. So let's find out first what is x. X plus 2 is equal to minus 5. So 2 goes there, will become minus 2. So x is equal to minus 5 minus 2. X is equal to minus 7. So we got our first answer here. Now we have 5z is equal to minus 20. So z will be minus 20 upon 5. We get z is equal to minus 4. We got two numbers. Let's find out y. Now here what they say, y square plus y is equal to 6. So we'll take that y square plus y minus 6 equals 0. So here this is one quadratic equation. So minus 6 has two factors, 3 and 2. So as 6 is negative, we'll take bigger number 3 negative. Y square minus 3y minus 2y minus 6 equals 0. So when you have two numbers, there is no factors with y square. So we know how the answer is. Plus 2 actually. So we'll get y is equal to, this is minus 3, so we'll get 3, or y is equal to minus 2. You have to solve this. Here I am taking a shortcut so that we can save some time. So these are the two values we are getting for y. So y, x is equal to minus 7, z is equal to minus 4, and for y has two different values since we are getting a quadratic equation, which we definitely know how to solve it. Correct? So just have a look at these sums. Again, let me remind you, if you have any doubts, you can post in the comments. Let's see a joke. Today we are going to learn a matrix. Not matrix, this matrix. Okay. Let's go ahead. Question 8 or question 9? Which one should we do? Let's do question number 9 since it has 4 variables. So here we have 2 by 2 matrix, means 4 elements. So we have A plus B equals 6. Then 3 equals D. 5 plus C equals minus 1. And AB is equal to 8. So here we have our 4 equations. Let's first find out the value of A and B. So here we take equation A plus B equals 6, and we also have AB is equal to 8. So what we can do, we can take A is equal to 6 minus B and we substitute in here. So AB is equal to 8. We substitute value of B there. B is equal to 6 minus B is equal to 8. So now if we multiply this, we'll again end up in a quadratic equation. So we'll get 6b minus b square is equal to 8. Let's rearrange this. We'll get b square minus 6b plus 8 equal to 0. So here we need to have two factors, two numbers where product is 8 and their algebraic sum is -6. So 4 2s are. Alright, so b square minus 2b minus 4b plus 8 equals 0. So let's take b common here, b minus 2, then minus 4 common, again b minus 2 equals 0. So we get into answer b minus 2, b minus 4 equals 0. So one of them can be 0, so we can have b minus 2 equals 0 or b minus 4 equals 0. So we have value of b is 2 or 4. So we got two values for b. Now that we got two values for b, let's find out value of a. So for a also we will be having two different values. Now value for a is, let me take a different a. A is, what is the formula? For a we have this formula, a is equal to 6 minus b. So if you substitute the values, 6 minus 2 and 6 minus 4, so we are getting two values, 4 and 2. A is equal to 4 or a is equal to 2. Alright, so we are done with a and b. Now let's focus on c and d. So for c we have equation here, 5 plus c is equal to minus 1. So 5, let's take 5 over there, c is equal to minus 1 minus 5, c is equal to minus 6. And for d is already there given, d is equal to 3. So you got all the values for value of b, value of a, value of c and value of d. Okay. So here we come to end of this exercise. Here is one interesting joke for you. Enjoy the joke and see you again later in second video with the second exercise. Please comment your doubts, subscribe for more videos. Thank you everyone.